Hello friends, today we prove these given numbers are irrational numbers. So let's start with 1 by root 2. So number 1, to prove this 1 by root 2 is an irrational number. Now let's prove this by contradiction. Let's prove this by contradiction. Okay, to prove 1 by root 2 is irrational number, and we are going to prove this by using contradiction. So suppose 1 by root 2 is a rational number. So any rational number is written in the form of a by b. So our 1 by root 2 is also equals to a by b, where these a and b are co-prime. Co-prime means their GCD is 1. There is nothing common between a and b, and moreover b is not equal to 0. And also note that 1 by root 2 is non-zero number. So a also non-zero. In this case a is also non-zero. Note 1 by root 2, this is non-zero number. Therefore a is also non-zero number. Okay. Now 1 by root 2 is equal to a by b. Therefore root 2 is equal to b by a. And as a and b are co-prime, therefore b and a are also co-prime. And moreover a is not equal to 0. That is root 2 is equal to b upon a. A and b are co-prime. Comma, a is not equal to 0. Therefore root 2 is a rational number. Root 2 is a rational number. But this is not true, because we already proved that root 2 is irrational number. So this is contradiction. This is contradiction to the fact that root 2 is irrational number. Root 2 is an irrational number. And therefore, why we get this contradiction? Because at the beginning we have assumed that 1 by root 2 is a rational number. So at end what we get, root 2 is a rational number. This is not true. Therefore our assumption is wrong. So 1 by root 2 must be a rational number, must be irrational number. Okay. Now second example, 6 plus root 2. So number 2, to prove 6 plus root 2 is an irrational number. So suppose 6 plus root 2 is a rational number. Okay. Therefore, this 6 plus root 2 is equal to a by b. Again, a and b are co-prime. With denominator b is not equal to 0. Now simplify this expression. 6 plus root 2 is equal to a by b. Therefore, root 2 is equal to a by b minus 6. So root 2 is equal to a minus 6 into b divided by b. Okay. Now cancelling common factor, if any, from denominator and numerator. That is, if there is a common factor between a minus 6b and b, cancel it, we get new numbers x and y such that root 2 is equal to x upon y, where this x and y are co-prime now, with y is not equal to 0. Because b is non-zero, so y is also non-zero. We have just cancelled common factor between a minus 6b and b. So root 2 is equal to x upon y. X and y are co-prime. So again this implies root 2 is a rational number. So again contradiction. So which is contradiction to the fact that root 2 is an irrational number. So why we got this contradiction? Again observe that at the beginning we have assumed that 6 plus root 2 is a rational number. So this is not correct. Therefore, what is correct sentence? Therefore 6 plus root 2 is an irrational number. Okay, now number 3. In number 3 we have to prove 7 into root 5 is irrational. So let's prove. Let's prove 7 into root 5 is irrational number. Again proof by contradiction. So suppose 7 into root 5 is a rational number. So by definition of rational number, 7 into root 5 is equal to a by b, where a and b are co-prime. They are co-prime, and moreover b is not equal to 0. So 7 into root 5 is equal to a by b. Therefore, root 5 is equal to a divided by 7b. Now again cancel common factors from numerator and denominator. So by cancelling common factor, we get root 5 is equal to x upon y, with x and y are co-prime. And y is not equal to 0. Why y is non-zero? Because b is non-zero, 7 into b is non-zero, and after cancelling common factors, this numerator also denominator remains non-zero. So root 5 is equal to x upon y. This implies root 5 is a rational number. Root 5 is a rational number. Again, this is contradiction, because in previous video we have proved that root of p is irrational number, where p is any prime. Here 5 is prime number, so root 5 is guaranteed irrational, but here we got root 5 is a rational number. So this is contradiction. This is contradiction to the fact that root 5 is irrational. Now again, why this contradiction? Same thing, at the beginning we have assumed that 7 into root 5 is a rational number. So again, this is not correct. So what is correct? 7 into root 5 is a rational number. Therefore 7 into root 5 is an irrational number. Okay, now last problem. To prove 3 plus 2 root 5 is irrational. Okay, so number 4. To prove 3 plus 2 into square root of 5 is irrational number. Okay, again we prove this by contradiction. So suppose 3 plus 2 into root 5 is a rational number. Therefore 3 plus 2 into root 5 is equal to again a divided by b. And what are conditions on a and b? A and b are co-prime. Moreover, b is not equal to 0. Now simplify this expression. 3 plus 2 root 5 is equal to a by b. Therefore 2 into root 5 is equal to a by b minus 3. So 2 into root 5 is equal to, now a minus 3 into b divided by b. So root 5 is equal to a minus 3b divided by 2 into b. Okay. Now again cancel common factors from numerator and denominator. So by cancelling common factors, from numerator and denominator, we get this root 5 is equal to x upon y, with x and y are co-prime and y is not equal to 0. So this shows that root 5 is a rational number. Again this is wrong, because root 5 is irrational number. So this is contradiction. To root 5 is irrational number. and therefore 3 plus 2 root 5 is an irrational number. 2 root 5 is an irrational number. Thank you.